In the previous videos, I showed you how an attacker can perform user enumeration and password guessing attacks against a login endpoint. In this video, I will demonstrate how developers can protect their applications from these attacks by implementing IP-based rate limiting on login requests. Whether you are a penetration tester or a developer, this video will help you better understand how rate limiting works, how it protects applications, and how weak implementation can be bypassed. To demonstrate these concepts, I have created a demo application that we will use throughout this video. You can set up this project from the GitHub Repository. I will provide the link in the description. In our application, we have two branches. The main branch contains the vulnerable implementation, while the secure auth branch includes fixes for these authentication vulnerabilities. We are currently on the main branch. Let's start the server. Now let's switch to the Burp Suite, open the browser and navigate to the localhost 3000. You can see the login page. Let's send a login request using an email address that we know exists in the system. As you can see, the response says password is incorrect. The first thing we want to do is test this email address against a list of passwords to perform a password guessing attack. Later we will see how to prevent this attack using IP-based rate limiting. First go to the HTTP history tab and find the login request we just sent. Now send this request to the intruder so we can automate this password guessing attack. Here is our login request. Let's perform a password guessing attack against this specific email address. Make sure the sniper tag type is selected. Next, select the password we previously entered and click the add dollar button. This marks the password field as the payload position. For now, I have a small password list that includes the correct password. Let's paste it here and start the attack. As you can see, one of the requests return a 302 status code, indicating a successful login. That means we have found the correct password. In this demonstration, we used only a small password list. However, if the application does not have proper protections in place, attacker can automate this process and try thousands or even millions of passwords against a user account. Now let's see how can we slow down attackers by limiting requests based on their IP addresses, so they cannot send an unlimited number of login attempts. To implement this in our application, we will use Express Rate Limit library, one of the most popular rate limiting libraries for Express applications. You can install it in your project by running npm install express rate limit. I have already installed and configured it on the secure auth branch, so let's switch to that branch first. Now let's open our login and sign up API endpoints. Here you can see two rate limiting middleware functions. These middleware functions executes before the actual login and sign up logic. Let's take a look at the login rate limiter. This configuration allows only 5 requests from a specific IP address within a 1-minute window. Once the limit is reached, any additional requests from that IP are blocked from the remainder of that minute. This means that even if the user enters the correct login credentials after exceeding the limit, the request never reaches the actual login controller. Instead, it is rejected by the rate limiting middleware. Behind the scenes, the library keeps the track of each client's IP address. For every IP, it records how many requests have been made within that configured time window. Once the request limit is exceeded, it starts enforcing the block until the time window expires. After the timer resets, that IP is allowed to send request again. Now let's run the server on the secure auth branch. Our server is running again, this time with rate limiting protections enabled. In Burp Suite, we already have our password guessing attack configured against this email address. Let's start the attack and analyze the responses. As you can see, I have loaded a much larger password list. However, the attack stops after just 5 login requests. Any additional login requests are blocked until the 1-minute time window expires, which is the limit we configured in our rate limiter. You can of course adjust both the maximum number of requests and the duration of the time window to fit your application security requirements. Keep in mind that rate limiting slows down password guessing attacks, but it does not completely prevent them. Without rate limiting, an attacker might be able to send hundreds or even thousands of login attempts per minute. After enabling rate limiting, they can send only a handful of requests during the same period, dramatically increasing the time required to guess a password. Determined attackers can still distribute their requests across multiple IP addresses or machines to bypass IP-based limits. However, doing so requires additional infrastructure, making attacks more expensive and significantly less efficient. If you are a developer, make sure to use well-tested and widely adopted rate limiting library instead of implementing rate limiting yourself. Writing your own implementation can easily introduce subtle security flaws that attackers may be able to exploit. Recently, I have completed the Broken Brute Force Protection IP block lab from the PortSwigger Academy. This lab demonstrates an application that has rate limiting implemented but not in a secure way. The application blocks login requests after a few login attempts from the same IP addresses. However, the lab shows an interesting weakness. If an attacker has access to any valid account in the application while trying to brute force another user account, they can bypass the rate limit. After reaching the request limit, the attacker simply logs in with the valid account using the correct credential. In this vulnerable implementation, a successful login reset the rate limiter counter back to the zero. The attacker can continue sending more password against the target account. This entire process can be automated in Burp Suite, allowing the attacker to continuously bypassing the application brute force protections. The important lesson is that this bypass works only because the application's custom rate limiting logic is flawed. Well-maintained libraries such as Express Rate Limit are designed to avoid this kind of implementation mistakes and are much harder to bypass using techniques like this. If you want to learn more about how to secure applications and how attackers try to break them, be sure to subscribe to this channel. I will sharing more practical hands-on videos on web security, authentications, and secure software development.